Yeah, disconnect.
Okay,
Seems
you
already.
resolve.
Yeah, yeah, okay. It seems much better than.
Okay, then try to.
Okay, then again.
We'll see.
We'll see.
If it works
Yeah,
better
yeah,
than.
yeah, we're not there yet.
Yeah.
Yeah. Connected, waiting, let's.
Okay.
Yeah.
So, welcome, welcome. Um, we are starting the session, but we are having some network problems. So, I'm running on IETF network and Benno is running on my phone. So, we'll see which one works better. Um, so, Benno.
Thank you. So, welcome to the DNSOP session 1, session for Monday. So, we start with a chair slide and present the agenda and give an update on what we have done. Bedo, Andre on my left. We have our, thank you. Schumann and Peter are our secretary. Schumann is remote, Peter is over there. Our area director is Matt, he's in the room. Yeah, over there, thanks. And right, let's go. Oh, that's important. Paul offered to take notes. Thank you, Paul. This is an IETF meeting, and the note well applies here to the working group. So, sorry, closer to the mic. Yeah. Is this better? No, I will. Oh, thank you very much. Yeah. Thanks. Yeah. So this is an IETF meeting, and the note well applies to the working group, to this session. So we assume you're aware of the note well and you've read it. Part of the note well is the, okay, that goes well. Part of the note well is the IETF code, conduct of, well, code of conduct guidelines. Well, won't go over the different points here, but we work as individuals and we go respectful with each other. So be kind and respectful to each other. If there are any concerns, please reach out to Andre, myself, or to the Ombuds team. We take this seriously. Good. Some meeting tips. So everybody in the room, I asked to register themselves by the quad code at the front or just before on the screen. It's important, so use your telephone or the full client on your laptop. That, and also, of course, for the remote people, but they are obviously registered. It's important for the IETF process. It's not everybody might remember the blue sheet, but we need the people in the room that attend the session. Good. Next is the agenda for today. We will give an update on the current work. And then, the hackathon updates, we will give that on Thursday, very brief. And we will go over the current working group business, then for consideration and time permitting presentation. Thanks. Yeah, document update. So we will give an update of all the working group documents, where they stand. Good. So we have published 3 RFCs in the past 4 months. They're all related to each other. Thank you, Wes, and the other authors. Here are 2 drafts in the RFC editor queue, operational guidelines for DNS transport, and the clarification of CDS and DNS key. The The operational guidelines just entered the editor queue, and the CDS consistency is for 60 plus days, but no problems expected, just making progress. Good. Submitted for ISG publication, not yet. There will be, this document will be soon submitted to the ISG. We had a working group consensus on the document DS automation, waiting for the Shepherd write-up, and we'll then submit it to the ISG, to our AD. Another document in working group last call is a structured DNS error. In February, we had well, let's start. Previous year, we had an IETF last call for this document, and it was sent back by the ISG to the DNSOP working group. There was some feedback we had to incorporate. It was more than just more than editorial changes, so the ISG sent it back to the DNSOP working group. We had an interim in February on the document, together with DNSOP censorship or censor transparency draft by Mark. The goal of the interim was both include, discuss, well, first discuss and then include the community feedback during IETF last call, and also make sure there were no conflicts between structured DNS error and the draft by Mark. It's just recently renamed to censorship transparency draft. So during the call or the interim, it was clear there were no conflicts. Community feedback was included. There was some additional feedback. So the authors were included all the latest comments in February, submitted a last revision, and we started a working group last call. The working group last call ended actually this week, but I want to extend it for this week until next week, early next week. I really want to ask you to read the document and give your feedback, if it's ready or not. In the interim, people were positive, so please, people in the interim, just send an email to the mailing list that you think the document is ready to proceed. Thanks. Oh yeah, and we got a very good DNSDIR review, so thank you, DNSDIR team, to be on top of this. Good. Other documents that are waiting for our go-ahead. It's NS revalidation. There was a working group last call end of November. The chairs are waiting for feedback by the authors, feedback on the feedback of the working group, and then we decide for consensus or not and how to go forward. Domain verification techniques. There was a lot of feedback. 2 new sections were added in the past 4 months, threat model and supporting multiple accounts and multiple intermediaries. We think it's ready for working group last call. I talked with one of the authors, thinks also is ready, but we have to decide and discuss it with all the authors and go forward. And we really want to finish this document. So if you have in the meantime some comments, look at the latest revision, share your ideas, your comments, your feedback on the mailing list, because we really want to push forward on this document. I think it's now going on, the document is about 4 or 5 years. Really want to finish it. Another document that needs some attention is DNSSEC automation. We are in discussion with the authors how to go forward. It's, yeah. Good. There we go. Is this? Next slide. Right. Can you go forward otherwise? Yeah, oh, there it goes. Yeah. Other documents in the working group that just continue to work are these. I won't number them. I want to discuss them. One thing, well, there are 2 new documents. Delegation management, or 3. RFC 9346 bis and DNSOP DELEXT, which is a document from DELEC, it's related to work in DELEC, but the work belongs in DNSOP. And so we accepted the document as a working group document. Good. There we go. I don't know. Can you try? Thank you. Right. Oh yeah, to one other new document, DNS dry run, and the other document, DNSOP integration, needs more working group discussion and feedback. We asked that on the mailing list. We got a DNSDR review. We think there's more input from the working group necessary to make to go forward with the document. So again, have a look at the document, give your feedback, and we also will ask it on the mailing list. Yeah. Yeah. Okay, that works. Right. So all together, before we go to the agenda, I think we cleared up quite a lot of work in the past months. We finished some work, pushed it to the ISG. We adopted quite a number of new drafts, so I think we're in a good shape now with the working group. But if you think things could be speed up, going faster or different, please reach out to the chairs. For today, the agenda. So a regular working group document update will be given by Johan on automated DNS delegation. Next are, all right, thanks. Yeah, that works. For 2 drafts for consideration, clarification to the DNS ranking data by Willem, and considerations for protective DNS operators by Mingxuan Liu. And then time permitting, thank you. Time permitting, avoid large records with wildcard owner names. The author is Peng Zhu. Presenter will be Bashan Zhu. Thank you. Any comments, questions about the agenda? Otherwise, we'll go start with the presentation.
Okay, so Benno asked for a feedback if you think there's any improvement, but we would also like to hear if you like the increased velocity of the DNSOP, like we chew through more drafts and so things are moving now, I hope. So if you have any feedback and you like what we are doing now, we would also like to hear that.
Thanks. Okay. Thank you. Then we'll start with the first presentation by Johan Stenstam. Okay, I can't do anything.
No?
No. All slots are... Me neither. Maybe you need to stop. Can you stop? Yeah. No.
Okay, am I close enough to the microphone? Oh, thank you. Yes, thank you. And that's forward, okay. So this is a presentation of a document that has been kicked around for, I think, close to 2 years, but now it's changed from an individual submission by us to a working group document. So we need a little bit of recap and statement of where we are. After adoption, we resubmitted with essentially no changes. And then before this IETF, we, made changes because it had been not exactly dormant, but we had worked more on the code than on the actual document for a while, and we needed to bring the document up to spec to where we were. So we've changed a couple of sections, we rearranged stuff, and we tried to make the document essentially a better document by clarifying stuff that wasn't sufficiently clear. I don't think we're done, but at least we're moving in the direction of improving the document. So a number of things have been improved. But what is this about? Well, it's essentially about the alternative of doing automated delegation management with a push model, where the child push the change to the parent through a signed dynamic update, as opposed to automatic delegation management through a pull model, which is what we do with various scanners. Obviously, push has advantages from an efficiency point of view, and it has new issues from an authentication point of view. So there are pros and cons, but if we get it to work, it's obviously an efficient and good model. It also has the very attractive benefit of working as well for unsigned child zones as for signed child zones, which is something we cannot do with parent-side scanners because they rely on the DNSX signature. So the child discovers where to send the update through a lookup of the desync record in the parent, now standardized. It signs the update when it has the need to change something and sends the update to wherever the parent wants to have the update delivered. And then in the recipient end, in the parent applies, well, obviously signature verification, but after the signature verification, it does exactly the same set of policy verification that it would have done had we done this the other way around through a CDS or CSync scanner. So there's no change to the parent-side policies. They are exactly the same regardless of the push or pull model. Likewise, there's no change to what happens after the update has been accepted, so to speak. It goes into some sort of whatever the parent wants to do with changes it discovers in children, be it a registry database or some other system. There is no requirement from the drafts point of view or from the prototype software point of view that this has to go straight into the parent zone, because that typically is not what you want. So once the update is approved and verified, it's essentially irrelevant whether it was discovered through a scanner or through a dynamic update. And then we get to the interesting part. The interesting part is, how do we gain trust in this key that the child is using to sign the zone? This is probably where we've spent most time. I mean, dynamic updates as they are not trivial. Oh, sorry, they are not difficult. The question is how to trust them and how to gain trust in the key that signed them. And right now we have a whole bunch of models for how to make the parent trust the child key. The initial model was, let's just publish the key at the apex of the child zone. And the parent can look it up there. And if the zone happens to be DNSX signed, we're done. Everything is fine. If the child zone is not DNSX signed, we're not fine, because then presumably that published key, which is not signed, could be spoofed. And then we're essentially in the same space as we have with CDS bootstrapping, where RFC 8067, I think, suggests that we query multiple times from multiple vantage points, et cetera, and eventually we gain trust in this key. So we can do the same thing in the unsigned case. However, there is also another model as advocated by RFC 9615, which is, let's publish the key as let's publish the CDS in the RFC 1915 CDS bootstrapping model under a name which is in a signed zone. And presumably in most cases, provider zones are signed. So if we publish the key somewhere under the name server name, that would be in a signed zone, and suddenly we could do DNS verification immediately, and we're done. As soon as we can find the key in a signed zone and DNS verification works, the initially hard problem becomes an easy problem. So we support both, and obviously we can also do various manual things. So in the end, the parent informs the child of what of these mechanisms for bootstrapping the key it supports. And it does that by publishing an SSCB record at the target of the desync record. So this is the same mechanism that we use for generalized notifications. We tell the consumer of the information in the desync what mechanism the parent that publishes the desync supports. And in this case, we're proposing a new SVCB param called bootstrap that is used to announce what bootstrapping mechanisms are supported. Another change is that just like the information from the child to the parent is, well, crucial and important and has to be signed and has to be verified, it's also the case that the information back from the parent to the child is, in some cases, crucial and important and ought to be signed. So we've switched to a model where we actually publish a key also for the update receiver end, so that the update receiver is able to sign the responses. That's typically an easier problem because the parent zone in most cases is signed, so we can just publish the key and the child will verify the key and everything is good. So it's an easier problem than in the child to parent direction. But even given that, one of the hard problems, or rather one of the crucial problems with this kind of system is that if I make a change to the parent side delegation information very infrequently, for an unsigned zone, perhaps I only change my name servers once every 2 years or something. It's not a frequent operation. What if it doesn't work? How will I discover when it stops working? It worked 2 years ago, and now suddenly it doesn't work. Something has broken in the meantime. And that is one of the reasons why we have the eDNS0 key state option, where we are able to communicate between the child and the parent. And for instance, we have several operations here, but one of the operations is that we can inquire what the state of the key is from the parent's point of view. So the child is able to say, what is the state? This is the key I'm using. Is this a key that you are still trusting everything is fine, or has something broken? And I can do that before I have an urgent need to actually make the change. So I can do this whenever I want. I can just ask the parent, and the parent will say something like, yes, this key is trusted, everything is good. If you send a dynamic update, it will work. Or the parent can say, no, as in whatever, algorithm is not accepted, or I'm in the process of bootstrapping trust for this key, or whatever has happened. And then the child obviously has the opportunity of rebootstrapping. So this is a parallel process that you can do separate from actually making changes to the delegation information, to make sure that when you have to make changes to the delegation information, it works. You don't want to discover after 2 years that, oops, this was a good theory, but in practice it doesn't work when I need it. So this is more or less a complete flow. And the child publishes the key at various places. He sends a query to the parent asking whether the key is trusted or not, what the state is. And then he gets the response back, sorry, I don't know that key. He sends a self-signed update to the parent, which is the bootstrapping starting point. And the parent does the verifications over DNS, DNSSEC verifications, whatever. It promotes the key to trusted, and now the child knows that the key is trusted, and we can send updates for whatever we want to update, be it NS records or DS records or something. The prototype implements essentially all of the things in the draft, and it works. We have made a lot of work on it recently, just again to keep the draft and the implementation in sync. That said, there are always more things to do. And there are a couple of things in our backlog that we intend to fix as soon as possible, which is probably before summer. That brings us to the draft. I think this is close to being technically complete. I mean, we've hashed it around several times. We have an implementation. The implementation works. We've found a bunch of issues that needed refinement. We've spent a lot of work on the key bootstrapping stuff, and we think that we now have a really good solution for that. So it's sort of technically quite done. But that said, I'm not sure that it's quite done from an editorial point of view. There has been lots of changes recently, and changes to the draft obviously introduce new problems in a draft. So we need to work on that, improve the readability, make it more precise in the specification part to make it easier to implement from, etc. So obviously we absolutely welcome all kinds of feedback and input on how we can improve the draft. Any questions?
Peter.
Hello, Peter Thomason. On slide 5, you said this is where the child authenticates the parent. Maybe we can go to slide 5. You said the parent is usually signed, and that's why the child can just query the key record and verify it. Now, this procedure is supposed to work with unsigned children, you said?
Yes.
And then, you know, you might want to have sub-delegations, so the parent actually might not be signed.
No, that's true.
So what do you suggest in that case?
There are essentially two methods, and those are the same two methods that we have in the child case. You can do RFC 8067 style and poke at it from different vantage points, or you can have the parent also publish underneath the underscore signal magic name thing that RFC 6517 proposes. So the problem is essentially the same. The only thing that differs is that the probability of the parent being signed is higher than the probability of the child being signed. Otherwise, it's the same problem.
Okay, then maybe there should be one joint description that applies to the parent and the child.
I agree.
And then, of course, you only use the name server-based signaling.
Yeah, no, I agree with that. That's a good point. More questions?
No questions. Remote. Okay. So we asked the working group, of course, to read and the latest revision and give comments on the mailing list. Thank you.
Yes. So this work has been presented exactly 1 year ago by Kazunori Fujiwari, the co-author of this draft. And there was a fair bit of feedback on the DNSOP list as well, but we let it slip a bit. So we are trying to restart it now. So the idea of this draft is to, I think we can still say, obsolete section 5.4.1 ranking data of RFC 2181. And replace that with directives whereby the source of the data determines for what purpose it may be used. So what's the problem with section 5.4.1 of RFC 2181? It sort of assumes a name server where everything is mixed and everything is in a single database with just one entry for every name, where the data associated with that name is replaced depending on where the source the source of that data. And it also assumes for authoritative name server function, for example, that all data from zone files and zone transfers are merged together. And this is no longer current practice. So on the right side is one of the scenarios that is supported by RFC 2181, where everything is in a single database. And also, the list only specifies priority of data and not validity. It doesn't say this data in this package should be ignored. It assumes that all resource records in responses or wherever it comes from is all stored in the cache, just with different priorities or just replacing existing entries if the source indicates more priority. And so this is also no longer current practice. Actually, unnecessary data should be discarded. Packets should be laundried if they are the results from a resolution process. So we propose to instead replace that section with a list of directives. Authoritative service must not merge zone data. So for example, when returning referrals, the glue must come from the same zone and not from other zones, which are accidentally also served by the same authoritative name server. Name resolution results, answers, annex domain, no data, must be authoritative responses with data from authoritative servers that have authority through delegation. Non-authoritative responses, like refill responses from authoritative servers, must only be used to query the delegated authoritative server during name resolution. So we should still have some work to do. Take out the word "the" in this. So for name resolution, the non-authoritative glue can only be used to get to the authoritative server, so to say. But towards the stub, only the authoritative data must be returned. Names and IP addresses of authoritative name servers for zones that are built in or loaded from hint files must only be used for priming. And this is new in version 1. Name servers with multiple functions that act as a authoritative and recursive resolver and or forwarder, depending on the namespace to which the query belongs, or the server IP address, or the query IP address in split horizon configurations, or the recursion desired bit. Now, is it addressing the authoritative function or the recursive resolver function? For those name servers with multiple functions, the data handled by each function must be completely separate and may not be mixed. We think there are some additional considerations to be added to that draft. So recursive resolver should only accept the following data from authoritative servers. So from refill responses only accept the NS and DSRR sets in the authority section and only related glue in the additional section. And from annex domain and no data responses only accept the SOA RRs and the NSEC and NSEC3. We need to add that too. And the answer section only accepts the data that match the query plus the signatures and any data for from the additional section only if it relates to the queried for name. And should not accept any other info or actually discard it. And so this is a bit more. So the draft still needs discussion, I guess. And so we currently have this as additional consideration. The additional section returned as the result of name resolution must be exactly the same as the additional section that came from the authoritative response from the authoritative server, or a separate authoritative response resulting from name resolution. But I guess what should also be added here is with this non-valid data discarded. So that's it. I would really like to restart this work. And yeah, I'm open to feedback now.
Jim Reid. Willem, this is great work. I think you and Fujibari deserve a great deal of credit for getting this started. Okay. The whole issue of ranking DNS data is something that's been left dangling for a long, long time, so more power to your elbow. I think this is a great idea. One concern I have with the existing draft, though, is that you seem to be mainly focusing on what authoritative servers are supposed to do when they're handing out data. I think we need stronger guidelines on what recursive resolver servers are going to do with the answers that they get when it comes to ranking the data. There is some text in there, but my impression reading the document is there's more focus on the authoritative side than on the recursive side, and perhaps that can be fixed in the next release.
Yes, okay.
So, Andre, with my ISC implementer's hat, I think this is useful, but and I would be willing to provide feedback. But my question is, with DELEG being around the corner, would it make sense to just like wait a little bit and incorporate the DELEG into this as well? Because when the DELEG is out, we would basically have to update the document.
Yes. So yes, I think that would be possible as well. This could fit this additional consideration, for example.
Ralphie Akamai, so thanks a lot for doing this, and I would certainly be willing to support and do reviews. There's one thing I think we discussed already that I have a problem with, and this is this one, because resolvers usually answer from cache and they don't store any additional data in the cache. So I don't think the must there is something you could get resolvers to agree on in the real world.
Yes, yeah, let's see how we can formulate this so it works, so that not the additional data that should not be there will not be returned to the step resolver.
Okay, thanks.
Jim Reid again. I just want to pick up on what Andre just mentioned a few moments ago. My preference would be get this document out the door as soon as we possibly can and not wait for DELEG to be finished. Once DELEG is finished, then we can perhaps have another document that describes the criteria that apply for dealing with DELEG-style delegations. I think we need to get this work progressed as quickly as we can, which is easy for me to say, and I know it's going to make work for more work for Andre and his colleagues, but hey, that's the nature of the business you're in. Says me, talk is cheap.
Okay. Would you like to respond? No. Thank you. Thank you all for your comments and your feedback. I do hear positive feedback. Also on the mailing list, I've seen positive feedback yesterday. So we will schedule your request for adoption, but first I have to ask Peter. He always keeps track of all the drafts that are to be scheduled for working group, call for adoption. Yeah, thank you. Next up, maybe, yeah. Yeah. Thank you.
Yeah.
Hello, everyone. I'm Misha from Zhongguancun Laboratory. Today, I'll present our draft of considerations for the protective DNS server operators. First, we want to illustrate that why do we need protective DNS? Sending DNS requests for domain names is the start of the navigation of the internet. And unfortunately, domain names are also frequently abused for various unexpected actions, such as malware communication. Therefore, blocking DNS resolution of unexpected domain names can effectively curb cyber attacks. And to block resolutions of these unexpected domain names, protective DNS was proposed. It is deployed on recursive resolvers. In theory, when a PDNS server receives a query for domain names that appear on its block list, it prevents access by rewriting the DNS response to return some secure results, such as resolve the domain names to a reserved IP address. And considering these lightweight defense benefits, though it has not been proposed for long, it has already gained some support from dozens of famous DNS vendors, such as Cloudflare. In addition, countries including the US, Canada, and Europe are also releasing the initiatives for deploying this national PDNS infrastructure. Although the increasing demand for PDNS due to lack of guidance, significant discrepancies exist in the current PDNS ecosystem, even some potential security risks. Therefore, our draft aims to provide specific operational and security considerations for protective DNS providers to make the service more usable and secure. And in our draft, we present operational considerations from 4 aspects. First is the block list selection. The vendors should define the types of domain names to be blocked based on their own intended use cases, and they should verify the correctness of these domains to avoid the impact of false positives. And they should select an appropriate block list source and deployment approach based on their own operational context, such as the device resources, constraints, and network access patterns. And then it's the rewriting policy construction based on their selected block list. They should select an appropriate rewriting approach based on their applicational requirements, such as using their controlled secure IP addresses or just return some empty answer section. And they should also consider the impact of the rewritten records of the TTL configurations because for the cache. And then they should also consider the performance impact of PDNS because there is some extended time for matching in the PDNS block list. And they should offer the explanation of their blocking actions caused by PDNS because PDNS action is totally black box for the end users. And more importantly, the deployment and implementations of PDNS need to avoid potential security risks from 5 aspects. First, to address the shortcomings of the rewriting policy flows, the redundant R data and missing R code tabs should be avoided to prevent the bypassing actions. And the rewriting policy coverage should be always maintained, such as for the encrypted DNS and IPv6. And second, if PDNS operators use the third-party network resources as the rewriting policy, such as the cloud resources, they need to regularly check the effectiveness of the resources to avoid the risks caused by the dangling risks. Then, excessive blocking actions should be approached with caution. On the one hand, when building the block list, avoid using some overgeneralizing target domains, such as just using the keywords or using the view card domains. And on the other hand, it needs to be considered that aggressive blocking could lead to a denial of response threat. And finally, they should also consider the interaction with data integrity protection, such as for the DNSSEC compatible, because this is some changes in the recursive results. And they also should prepare some fallback mechanisms and for any possible fault during the PDNS operation. And now our draft has been updated from the version 0 to version 1 from some recommendations from the DNS consulting. And also we are still highly welcome some feedback from the DNS community and the PDNS vendors. Thanks for listening. Any question?
So, hi, this is Andre. I see with my chair's head. Before I say what I have to say, so it's up for the working group. We take this work, but I think this is not a good work to be an RFC because this is a landscape that changes a lot very quickly. And before the DNSOP stops with this and it goes through all the processes, it will the DNS landscape will be different. So I would suggest what Peter was saying a couple of meetings back. There's now a DNS.org best practices initiative that might be better suited for documents that changes a lot, because the DNSOP is not known for fast work. So, but it's up for the working group to decide whether there's enough people wanting to work on this. But my opinion is this is like a complex document, and I don't see a reason why this should be a RFC.
Okay, thank you. But I want to add some comments. We already measurement in the whole network for the PDNS operators, and we find that nowadays the PDNS providers is more and more in the network, but there is more the operational flows and even some security risks. We already found that. So I think it can be just a draft to recommend the PDNS vendors how to deploy the PDNS service. Thank you.
So we have quite a long queue, and we also want to have the final presentation in a couple of minutes. So please be brief. Thanks.
Stefan Bartsmeyer. I agree that it's not a good idea to have such a document for DNSOP, because there are many things. There are things about political issues, because protective DNS can also be used for other things such as censorship, which raise a lot of issues. There are technical questions about the DNS, which are in the DNSOP domain, but there are also things that are completely out of scope, such as management of the block list. I don't think that the IETF has anything to do or to say about this. Also, the current tone of the draft is very like an advertisement, simply calling that protective DNS, while the official DNS terminology, RFC, talks about policy resolver, if I'm correct. Protective DNS seems an endorsement of this practice, which is very questionable. So I agree it's not a good idea for DNSOP today to work on this document. What could be interesting for DNSOP would be a document limited to the DNS as technical aspect of such lying resolvers.
Thank you. I don't know. I followed all the content, but I think that our drafts give some technical recommendations, may I right? And just due to the time limitation, and we don't represent all the draft document content. And if you have the question, we could communicate offline. Okay, thank you.
Yeah, thank you. Next Ben Schwartz.
Hi. Yeah, I don't think we should move forward in this case because I don't think that there's any real possibility of getting IETF consensus for a document like this. Any RFC, any document that we adopt in the working group for publication ultimately needs to not only reach consensus within the working group, but reach consensus from the entire IETF community. And I really don't think there's any likelihood of that with this material. I also want to point out that the draft as currently specified conflicts with a number of other existing DNS specifications. It conflicts with the extended DNS errors draft. It conflicts with DNSSEC. It conflicts with the guidance for resolver operations generally. So I would want to see I think any version of this that we could adopt would have to be pretty substantially changed so that it no longer, for example, recommends synthesizing wrong answers in the R data for A queries. So I think that I agree that there are venues out there where advice of this kind would be appropriate, but I don't think that the IETF standards track is the right track. And notably, the current document describes itself as standards track.
Thank you, Ben. And yeah, you might also send an email to the mailing list or directly to Mengqian. Yeah, and so for Vittorio and Campalo, can you just state yes or no, because we have nearly no time. And
okay,
so are you supporting the document or not? And
I would need to say more than this. So I just wanted to thank the person for bringing this document. I think it's not very kind of us to meet her saying just go away, since they are newcomers to the IETF. So yeah, I agree this is not fit for the standard strike of theirs, but I'm happy to work with you to make it either an informational FC or somewhere else in another venue. Thank you.
Thank you, Vittorio. Yeah. Thank you.
So very quickly, it cannot be a yes or no, but I think it's very interesting the part of to add the transparency to the protective DNS. So I have the reason. So I think specifying that a protective DNS solution has to show the reason of the blocking so that the customer can protest. Thank you.
Thank you. Okay, then we have the last presentation. Thank you.
So thanks for the opportunity. Sorry, 12, so I'll keep it short. My name is Bashan Zuo from Cynic. I'm presenting this on behalf of Peng, and this draft is about avoid large wildcard records. The problem is fairly simple, and there's no camel involved. DNS does not have explicit size limits for TXT records, so operators can publish large TXT records under wildcard names. Because of wildcard names, queries can bypass resolver cache and keep triggering large responses. And those that can lead to high bandwidth cost and raises operational concerns. So the goal of this draft is not to define a strict limits for TXT records, but to provide operational guidance on how limit should be applied, and specifically for the wildcard owner name. So here is a simple example. So we put a set of TXT records under a wildcard names, and we send a small query. We got 34 answers back, and the message size is hitting the limits, and that's pretty much the most that you can get from a query. And the whole thing creates a huge amplification factors. So it's quite easy to generate such query, and those query can be sent through public resolvers or can be sent from compromised host. Or they can be triggered from a web page using JavaScript or DOH. And so if a DNS server keeps receiving queries that requires large responses, then there will be a lot of TCP connection overhead, and the bandwidth cost can become quite large. Resolvers may also consume a lot of memory if those large responses are cached with long TTLs. So all of this can result in slower response times in shared hosting environments, and that's really bad for the DNS hosting provider. And what they can do in practice, well, we bought a few domain names from those different providers, and we tried out their service, and it turns out that most of them, they don't have limits on TXT records, and most of them, they do have limits on A records and quad A records. I didn't list all of them here. So we try to let them know. We reached out some of them about this risk, and some of them actually made changes, such as setting limits, returning a smaller response, or applying rate limiting for a query over TCP. And others don't seem to care, or they don't see it as a problem. So at the same time, we try to propose something. We try to propose something that is concrete or more determinist. And there's two questions for TXT records and probably for other records. What's the minimum size requirement, and how large is too large? We don't know, and probably they don't know either. But they already said, even they already set the value there. So in this draft, we try to start with providing a operational guidance rather than setting strict limits. So DNS hosting provider, they should have, or they can have something to follow in the first place. And the exact limits can depend on different situations then. So we suggest DNS hosting provider, they should avoid large TXT records under wildcard names, or more generally, they should avoid large records under wildcard names. And this can be done either by refusing to accept oversized records from their user, or by returning smaller response size, or by returning smaller responses if they don't really want to give their user explicit limits on any records. So next, here, I just want to briefly mention there's some established practice in discussions. They all try to reduce the response size, and this draft follows the similar idea. But we are more on the wildcard owner names. So what do you think? This idea is a good proposal or a bad proposal? And let us know, please, on the mailing list. Thanks.
Thank you. Okay, Gianpaolo, your hand's still raised. Was this for this session? Okay.
So I'm the guy that says no. So this is a question for the working group, but is it worth? Is it just this idea like limit TXT, worth an RFC? And it might be, there's a Fujiwara-san's draft on the limits in DNS. It might be just folded into paragraph in that draft, and it might be better use of our time.
So Warren Kamari, yeah, I mean, I guess it could fold in somewhere else, but it also feels like this is DNS operations. And so we should be able to do like really short one-page RFCs being like, here are some bad ideas, here's ways to make them less bad. Ideally, like it should be easy to do things fast. I'm not saying it is, but.
Okay, thanks.
Johan Stenström, agreeing with Warren. I think if we really must have a mechanism to deal with simple things fast.
Yeah.
Adopting something should not necessarily be a 3-year process.
Yeah.
Please join the queue.
Yeah.
I did.
You're giving a bad example. No, oh yeah, you did.
Yeah.
Sorry.
Sorry. So, I mean, because we don't seem to be able to do things short and quickly, there's talk about starting up competing series in other venues, right? Like DNSORC and stuff. I think that's a failure that we,
Yeah. No, thank you. And it's a good that you mentioned that some documents should proceed fast. And we also discussed that with our AD and between ourselves. So that's also one of the things we are really on top. That's relative simple drafts should proceed fast. So it is not specific for you, but more in general, the working group, we want to speed up things. And with adopting working group drafts, or the call for adoption, we also look at relatively, well, I shouldn't say simple, but drafts that can be pushed forward fast. And the more drafts that need more attention and discussion in the working group and find this balance. Yeah.
But that depends on the working group members, not on the chairs. So if you want the drafts to go fast, there needs to be people who review the drafts, provide comments, and push things forwards. We can do as much, but we are not the kindergarten teachers. So we are DNS working group chairs, and it's up for the working group to process the drafts fast.
So, okay, thank you. So back to your draft. So we did hear some positive feedback, some considerations. So I think it's good to have continued discussion on the mailing list. I don't see people here in the queue. Thank you for your presentation, and please ask for comments, or I also ask for comments and feedback to the mailing list on the draft, and from there we will continue.
Sure.
Thank you. We're almost there. I want to give 2 announcements. Tomorrow morning, 8 o'clock, there's the post-quantum DNSSEC side meeting. Peter is chairing that, Peter Thomason. This afternoon at 2 o'clock, there will be the Ops area meeting on DNS at IETF. So Wes Hardeker will give a presentation. He did a community consultation about work, the DNS work in the IETF, and specifically also the workload in DNSOP and how to manage that and maybe split, etc. That will be at 2 o'clock at the Ops area meeting. Anything else? I look at Matt. Anything else? No? Then can we close, Andre? We close this session. Thank you. Thanks for your attention. And see you on Thursday at session 2, DNSOP.